Time complexity is not about calculating the time like 5 minutes an algorithm took. No, it is about calculating the operations an algorithm took like n operations. But it sounds very complex, right? So let's get into the details of it. We know that every function algorithm runs in steps. So suppose a sum function, this is step 1 and this is step 2. This is step 1 in sum program, this is step 2. So I can divide a whole function into steps. Let us take an example of sum function. When the execution starts and execution ends, in between there are steps. We are not considering time, so focus. Even though the topic is time complexity, but we are still not considering time, but we are considering is steps. So the total number of operations, we have to calculate what? The total number of operations. Learn this line. So let's start with topic time complexity. Every algorithm's running time depends on various factors. One is architecture, कि your laptop is 32-bit or 64-bit. Another is single processor, read-write speed, configuration, lot of things. Because every computer is different in configuration. Another thing is input. The input we just gave here for the sum A, B are inputs. We are dividing them into two parts. One is constant and second is variable. So we are considering the input value as variable and rest of the factors we are keeping it into constant umbrella. So for the simplicity, we are just going with assumptions. Assumptions are really important. We can't go into detail of these things like architecture, single processor. No, we are just going to focus on the input. And based on the input, we are going to calculate the time complexity, which is number of operations. Time complexity definition is time, but we are not calculating time in seconds, कि how much this algorithm took time. No, we will calculate how many steps this algorithm took. So focus on the steps, not on the time. Time complexity. Time complexity itself has a word time, but how weird it is that it does not mean that it is going to calculate the time an algorithm takes. No, it does not mean the algo time. No, what actually time complexity mean is, so we are not going to calculate the time it took. We are going to calculate the operations. What are operations we are going to just study. I want you to know that it is not about calculating time. It focuses on steps. So time complexity is represented as T. N is the input. Let us go with an easy example. Let's start with the simple variable declaration. So this is one line of code in which we are doing assignment of a number. So this will run for one time. We consider its time complexity is 1. So the time complexity of this line is Tn equals 1. So basically whenever you will see an assignment running on one step or one time, it will be constant one time. I believe you know for loops and know this logic. So in for loop, you have 3 parts, 1, 2, 3. One is the initialization. So this happens only one time, and this is the assignment. We just did assignment, so we will give it 1 unit. Second is I less than n. If you know, this runs n plus 1 times. How? Because it fails at 4th step. So but it runs now. So this is n plus 1. and this n plus 1 runs for n times only. It will not run for the failed case, it will run for only n cases. We can calculate the total by doing sum 1 plus n plus 1 plus n. So the total will be 2 plus 2n, and this will be 1 plus n. And as per the rule, ignore the constants. So after ignoring constant, we will be left with n. So what is the answer? So this for loop runs for n operations, n times. This was 1, this is n. And if in the loop we are writing any logic, suppose this is also assignment, it is going to run for one time, but actually not one time, we are looping now. So when we are looping n times, this will also run for n times, so it will be n. This line runs for n time, this line run for n time. So what we can do, n plus n, which is 2n. Again ignore the constant, we are left with n. So n is the operations, or n is the time complexity. Now we will do 2-3 more problems in next video.